Alright, in this video we will continue our practice of solving right triangles, finding all the unknown sides and angles. Let's pick up with number 6. In number 6 we're not given any of these angles, so we're going to have to solve for these angles. Now when you're looking for the angles, you know you're going to wind up using inverse trig functions. So let's just pick an angle and go for it. For example, say if we want to find angle U. And then of course we've got the 23 and the 7. So the first thing we have to do is decide which trig function we're going to use. Well, from the perspective of the U, this 7 is opposite because it's across from, and this 23 is the hypotenuse. So some students will accidentally say adjacent because it's close to, but when we say adjacent, we're talking about the leg, not the hypotenuse. The hypotenuse is always the hypotenuse. Okay, so we have the opposite leg and the hypotenuse. So which trig function is that? That is the sine function, all right? Sine of the angle is opposite over hypotenuse. So let's go ahead and set up the sine function, and we'll say sine of angle U is equal to the opposite leg over the hypotenuse, so 7 over 23. That means angle U, okay, again, if you want to find the angle, you need to use inverse trig function. So angle U will be the inverse sine of 7 over 23. And you must show this step. This is a horrible U. Let me try that again. All right. Do not just go straight to the calculator. Show this step. But now we'll go to the calculator. Inverse sine of 7 over 23. Okay, so inverse sine of 7 over 23. So that's 17.7. Okay, so U is 17.7 degrees. All right, now once you find one of the angles, you don't need to use a trig function to find the other one, because the two acute angles in a right triangle have to add up to 90. So the fastest way to find the measure of angle S is to simply do 90 minus the other angle. So 90 minus 17.7 will give you the measure of angle S. All right, so that's 72.3. Okay, so that is the measure of angle S. Okay, so we found the two angles. All right, the only thing missing is the third side. We haven't found the third side yet. All right, I'm cleaning some of this up. Now, to find the third side, we don't need trig functions at all. All right, so we're trying to find this. In fact, instead of calling it X, I think I'll just call it UT. If we have two sides given and we're looking for the third side, we will use the Pythagorean theorem. Good old a squared plus b squared equals c squared. Just remember to put the hypotenuse as the one that's by itself in the equation. So it's going to be like this. UT squared plus 7 squared is equal to 23 squared, right? Leg squared plus leg squared equals hypotenuse squared. The Pythagorean theorem, of course. So this is going to be UT squared plus 49 is equal to 529. All right, of course, subtract 49 from both sides. that's 480. So ut squared is equal to 480. Of course, to unsquare this, we will take the square root of both sides. All right, normally we'd have to do plus or minus here, but you can't have negative lengths, so we don't have to worry about it. All right, so ut equals, if I do the square root of 480, okay, that's 4 radical 30, interesting. Okay, well, let's go ahead and write that as a decimal, like the rest, by hitting the toggle key. So 21.9. Okay, and there's your final answer. So that's number 6. All right, looking at number 7. We need to find 2 missing sides and 1 missing angle. I'm going to go ahead and try to find MD first. Okay, so just for fun, I'm just going to put a little MD here to remind me that that's what I'm all about. So, I have this angle, I have this side, and I'm looking for MD. So, I need to decide which function this is. Have you figured it out yet? Well, from the 51, this 14 is opposite, all right, because it's away from the 51. This MD is adjacent because it's right next to the 51. Okay, the VD here would have been the hypotenuse. So opposite and adjacent. Now, which trig function is that? Well, that is our tangent function. Why is that so big all of a sudden? All right. Oh, yeah, our tangent function is opposite over adjacent. So that's the one we're going to use. So we will go, fine, tangent of 51, all right, always put an angle here, is equal to opposite over adjacent. So 14 over MD. You know, you can use an X or something if you want, but in the end, you better put MD so I know what you're talking about. Now, so if I want to solve this for MD, this is one of those ones where we're going to use the shortcut. If you have something that's equal to a fraction, if it's helpful to you, you can always switch the denominator with the thing that's out here by itself. Okay, so if I use that shortcut right now, the MD is going to come out here by itself, which is cool since that's what I'm trying to solve for. And the tangent 51 will become the denominator. So I will have 14 over the tangent of 51. Okay, so I'm finding MD. So I can just put this in my calculator. 14 tangent 51. Okay, so I'm going to go 14 over, whoops, I said 14 over tangent 51. So that is 11.33, I forget what we're rounding to now. 1 decimal place. So 11.3. 11.3. And there are no units here, so I'll just leave it at that. MD is 11.3. Okay, great. I found MD. Check. I also need to find VD. Now, do not use the 11.3 and then do the Pythagorean theorem. Don't do that because you had to round your answer to get the 11.3, so this is not exactly correct. And what if you made a mistake? Don't get 2 wrong answers for the price of 1. Okay, so I'm still going to use my 14 and my 51. But this time I'm looking for VD. So that's this. VD is right here. So which trig function am I going to do now? Since VD is the hypotenuse. Okay, so I've still got the opposite leg here, and I've got the hypotenuse. So which trig function is that? That doesn't help me. Opposite hypotenuse, that's the sine function, sine of the angle. So I will do sine of 51. And that must equal opposite over hypotenuse. So I almost wrote opposite. What I meant to write was 14 over VD. Okay, that's the opposite over the hypotenuse here. Okay, now, this is just like the last problem. Whenever the variable is in the denominator, it would be helpful to reverse these two. So let's do that. So I'll put VD is equal to 14 over sine of 51. All right, you have to show all of these steps, 3 steps. Set it up, swap it out, and then put the answer. You can't skip any of these steps. Whoops, didn't mean to do that. All right, 18.0. All right, so that is VD. So we found the 2 missing sides, MD and VD. Okay, there's still one more piece that we need, and that is angle V. The fun thing about angle V is that we don't need to do any trig functions or inverse trig functions either. If we're given one angle, you can find the other angle simply by subtracting from 90. Okay, in other words, angle V should equal 90 minus 51. All right, clearly that is 39 degrees. And that's all there is to it. So that is how you do number 7. Let's move on to number 8. Okay, so we're missing one angle and we're missing 2 sides. So this is going to be almost identical to the problem that we just did. All right, so let's start off by finding TR. All right, it doesn't really matter what you start off with, but I'm just randomly picking TR. So looking at the thing that we're trying to find and the 2 things we're given, which trig function is this? Well, from this angle, TA is the hypotenuse, okay, and that's not one of the 2 things we're given. So this is a leg, it is the adjacent leg, because it's right next to the 24. And the TR is the opposite leg, because it's across from the 24. So opposite and adjacent. Let's see. Opposite and adjacent, that's the tangent function. So let's set up the tangent function. So we will say tangent of 24 degrees is equal opposite over adjacent. So TR over 33. And right about now is where we will multiply by 33. Notice we won't do any swapping or anything. That's only for when the variable is in the denominator. When the variable is in the numerator, you just want to multiply. Okay, that way these 33s will cancel out, and we will just have we'll have 33 tangent 24 is equal to TR. Okay, so I can just put this in my calculator. So that gives me 14.7, got to round up. Okay, so that's TR. Now we have another side to find. So let's think about what that is. Okay. The other side we have to find is TA. Now TA is the hypotenuse. So that means at this point, okay, let me highlight that. We've got an adjacent leg, well, the adjacent leg and the hypotenuse. What trig function does that remind you of? No, that didn't help. Adjacent leg, hypotenuse, that's the cosine function. So that's what we're going to do. Okay, so we will, is there space underneath here? I don't know. Okay, so we're going to do the cosine function. So we'll do the cosine of 24 degrees is adjacent leg over hypotenuse, so 33 over TA. Now, is this one of those problems where I'm going to do that swap thing, or is it one of those problems where I'm going to multiply on both sides? Swap thing, okay, because when the variable is in the denominator, it's helpful to swap these because then the variable is by itself immediately. So TA is equal to 33 over cosine 24. So this will enable me to find TA. So that's 36.1. Okay, so we found the two unknown sides. The only thing that's left is the angle, the unknown angle. But when you just have one missing angle, it's super easy because we're looking for angle T, but angle T is just going to be 90 minus the angle that we're given. Okay, so I feel a 46 coming on? No, that can't be right. Okay, it's 66. Alright, and that is it for number 8. Alright, this video is getting long enough. I'm going to stop the video right here. I will see you on the next video picking up with number 9.